People need warning time before an impact. This is what happens if they don't have it. This unanticipated visitor from space was about 17 to 20 meters in diameter. Its mass was about 12,000 to 13,000 tons, metric or short. It doesn't matter. Here are some interesting size comparisons. The Chelyabinsk impactor is the second smallest object in the picture. The Hoba meteorite is an iron meteorite and is the most massive meteorite ever found on Earth. I think the Tunguska impactor was a small asteroid rather than a comet fragment. What I find rather frightening about the Chelyabinsk impactor is that so much damage and so many injuries were caused by such a small object entering our atmosphere. Its entry speed was about 65,000 kilometers per hour or 42,000 miles per hour. It had its terminal burst at an altitude of about 30 kilometers. The total energy released was equal to 500 kilotons of TNT. It briefly outshone the sun by a factor of 30 for someone directly below it at its brightest. Most of the mass was deposited at the 30-kilometer burst altitude in the form of a thick dust trail. Here is the dust trail with some annotated dimensions. Even though the burst altitude was 20 miles high, the shock wave from this small object still injured people and caused significant structural damage. Most of the fragments that survived to reach the surface of the Earth were very small. The biggest fragment crashed into a frozen lake. The largest fragment weighed 650 kilograms, about 1,500 pounds. Here is a piece of the Chelyabinsk impactor that fell to Earth. The scale at the lower right shows that this fragment is about 4 centimeters across, or approximately 1.5 inches. The exterior has a dark fusion crust formed by the heat of the object's atmospheric entry. The interior has a lighter color and shows a structure of partially melted chondrules. This fragment reveals that the impactor was an LL5 chondrite. You can visit Wikipedia for more information on this type of meteorite, plus that of others. Close analysis of this fragment shows that the impactor suffered 8 violent collisions since its creation 4.5 billion years ago. The most recent collision was about 27 million years ago. The orbit of the impactor brought it almost as close to the Sun as the planet Venus. At its farthest from the Sun, it was in the main asteroid belt where it was created. Asteroids with this type of Earth-crossing orbit are termed Apollo asteroids, named after the first asteroid discovered with an orbit like this. No one saw its terminal approach because it was in the daytime sky only a few degrees from the Sun. We did not know it was headed our way until we saw its blazing descent through our atmosphere. The shockwave caused structural damage, mostly shattered windows and some blown-in doors, but it also collapsed the roof of this factory. Fortunately, no one was in this part of the factory at that time. But there were injuries. About 1,500 people were hurt, mostly by flying glass. Because the impactor was briefly 30 times brighter than the Sun, witnesses said they felt a very hot flash on their faces. Over 100 people reported eye pain after looking at the bright fireball. About 70 people reported temporary flash blindness. 20 people reported the equivalent of sunburn. One was burnt badly enough that his skin flaked off over the next 2 or 3 days. This was about as energetic an impact event as it is possible to have without fatalities. If the impactor had been a bit larger or denser so that it penetrated more deeply into our atmosphere, producing a stronger shock wave, the fragment of glass would have been driven deep into this man's brain, or perhaps even all the way through his head. The Chelyabinsk impact event startled the world. Without warning, a near disaster fell from the clear blue sky. It was another example of the universe's indifference to our existence. Because of this, we must manufacture our own protection. But this event causes people to say, "What? I thought we were already protected. I know we can't move these things aside or blow them up. The only thing we can do now is to flee a predicted impact zone. But don't we have telescopes that are supposed to find these things? What happened? Why didn't they see it?" In the size range from 10 to 100 meters, NEO population estimates give over 20 million objects. That's a lot to try and find. Yes, we have telescopes that search for near-Earth objects, but telescopes, like anything, have their own limitations. They can't work when it's cloudy, they can't work in the daytime, and their effectiveness is greatly reduced by bright moonlight when it's near full moon. Let's have a look at what optical search telescopes can do in one night. This is a search telescope sky coverage plot for June 16, 2015. 5 surveys reported observations for that night. There are more than 5 stations. The others did not report either because it was cloudy or because of technical faults. Those stations are distributed around the world, so one day means every station experienced one night. At the bottom of the plot, you can see the identifier codes for each survey, such as 926 or F51. You can see the color-coded search grids for each reporting survey in the plot. Those search grids are built up one square at a time, so it's easy to see how something could slip by unnoticed. What is disturbing is that some nearby NEOs can pass through the Earth-Moon system in one day. As many objects pass by undetected on the day side of the Earth as pass by detected or undetected on the night side of the Earth. June 16th was the night of a new moon. The sky could not have been any darker for those who were not clouded out. One asteroid with an Earth-crossing orbit was discovered on this night. Follow-up observations established that although this asteroid's orbit is Earth-crossing, it will not be a hazard to the Earth. So there it is, the best efforts of the human race, over 7.5 billion people, to detect near-Earth objects in one night. Doesn't seem like quite enough, does it? Let's add up the 7 nights from June 10th to June 16th to see the total coverage. This looks better as there is more total coverage and some of the fields have been reobserved because NEOs can approach close enough to be detected in the interim. The black area from upper left through lower center is the part of the sky in which the Milky Way appeared during this period. The star fields of the Milky Way are so dense that it is very difficult to spot a faint moving object against this stellar background. so the surveys avoid the Milky Way. The hope is that the Milky Way will not hide an inbound NEO impactor. Let's now add all the survey fields for the 14 nights from June 10th through June 23rd. This is even better, but still many objects go by unseen, and we also still have the big Milky Way gap. For the period of June 10th through June 23rd inclusive, 25 asteroids were discovered with Earth-crossing orbits. 3 of these have orbits that make them potentially hazardous asteroids. The overall message is that if an NEO is in the night sky for a week, it has a reasonable chance of being detected. And it's even better if it's in the night sky for 2 weeks. But one night is not enough to establish a well-determined orbit for an object. It's difficult to detect the small objects that move through the Earth-Moon system in a day, and we certainly will not see them in the daytime sky. As I mentioned earlier, bright moonlight reduces the detection limit of the optical survey telescopes. In some cases, they don't observe for a few days on either side of full moon. But it gets even worse. A significant number of optical survey telescopes are located in the American Southwest, and they experience the annual monsoon. Some surveys shut down for a month or more. Radar would not. After going through all of that, why was the Chelyabinsk impactor not detected before it hit? Every few years, the Chelyabinsk impactor passed fairly near the Earth. The best recent opportunity was in early 2006. Unfortunately, at that time, the Chelyabinsk impactor was just a little too dim for the survey telescopes to discover it. More optical search telescopes will come online in the near future, but they're still subject to the same limitations as all of the other optical search telescopes. We need near-Earth object search and tracking radar, so we won't be taken by surprise again. Let's make radar our new friend. Because in this case, we need all the friends we can get. Hello, I have an update for you. Since I first made this video, there are more telescopes searching the night sky for near-Earth objects. There are now 4 telescopes in Hawaii that search for near-Earth objects. There is also another telescope like this in Chile, and there is a 4th telescope like this in South Africa. And that's a great improvement. However, we're still missing about half of the objects that go by. So we still need radar as much as ever. The radar is also based on Earth. A quick word about this image. When searching for asteroids, a telescope tracks at the rate the stars move across the sky. This makes the star images appear as little round dots. While orbiting the Sun, an asteroid moves against the background stars as seen from Earth. Because of this, the asteroid betrays its presence by leaving a trail across the image. This exposure was about a minute long. The stars stayed still, but the asteroid moved. This asteroid was far too faint to be seen without a telescope. This image covers only a very tiny part of the sky. Had the asteroid been bright enough to see with your eye alone, you would not have seen it move during this 60-second exposure. It would have taken about 6 hours for its motion to become plainly apparent. So asteroids do not flash across the sky like meteors. They just amble along at their own slow pace, until they sneak up on Earth and scream down through our atmosphere. And then they move across the sky very quickly indeed. This is a discovery image of asteroid 2007 TU-24. It was discovered on the night of October 11th, 2007 by the Catalina Sky Survey of the Lunar and Planetary Lab of the University of Arizona. It is about 250 meters in diameter, or about 800 feet. It can come rather close to the Earth, but is not an impact hazard for the foreseeable future. So rest easy.